Algebra, we are talking about CO5, which you see in the objective today, says scientific notation. I don't know how math got stuck with scientific notation. It seems like a sciencey thing, but here we are. And so the whole point of scientific notation is when you're dealing with really, really, really big numbers or really, really, really small numbers, having a different way to write them. Because, if we're talking about how far the Earth is from the Sun in feet, it is 491 billion feet, approximately, from the Sun. Okay, so go ahead and write in there 491 billion feet from the Sun. And we're going to write that number again. 491 billion.
Okay.
And again, take complete notes, people. Make sure you're writing this just as many times as I am. Really good way to practice circles. Those zeros there.
That's how much money I have.
And here's the thing. If you were writing an essay on, solar system, something like that, you might have to write 491 billion a lot of times. Okay? And since this number is just a 4, a 9, a 1, and then a whole bunch of zeros, what's the point? Right? And so instead of having to do this over and over and over again, we have developed scientific notation, which again is a way to write either really big or really small numbers using powers of 10. Scientific notation is a way to write really big or really small numbers using powers of 10. Because, let's write the definition down. A way to write really big, I forgot the word really small. I feel like that's kind of funny. A way to write really big or really small numbers using powers of 10. Because here's the thing. When you multiply something by 10, what happens?
You just add a zero.
Just add a zero onto it, right? Essentially what's going on is the decimal point is moving over. Right? If we start with like 9, and we multiply 9 by 10, 9 becomes 90. If we multiply 9 by 100, 9 becomes 900. Right? The more we multiply by 10, it just moves that decimal point over. So something like 491 billion, the scientific notation for this would be 4.91 times 10 to the 11th power. 4.91 times 10 to the 11th power. Who can make the connection? Why is it 11? Why 10 to the 11th power, Gabe?
Because it's 4.91, not 491.
Okay, so to get from 4.91 to 491 billion, how many times do we have to move the decimal point? 11 times. One common mistake that folks make here is they make their power just how many zeros there are. That's not quite the play, okay? Our decimal point has to go, so there's only one number before it. That's where 4.91 comes in. And then to get to this big number, yes, we've got 9 zeros, but we also have the 9 and the 1 to get past as well. Right? Yeah?
Why don't you just do 491 times 10 to the 9th?
Because scientific notation specifically says you can only have one digit to the left of the point. Okay? Because sometimes, it's not going to be 491. There will be 3 numbers there. Maybe it's, 491,800,000. Now we have 4. Right? So it's always just one digit to the left of the point, just keep things consistent. And then how many times that decimal needs to be moved to get to the end of the number. Okay? Let's look at some here. What do you got? says the goal of scientific notation is to move the decimal point left or right until there's only one non-zero digit before the decimal. Let's do a few together. So right now, this big number here, our decimal point is at the very end. How many movements will it take to get one digit to the left of it?
6.
6. 1, 2, 3. And this is why commas in numbers can be helpful. It kind of breaks it up into groups of 3. 1, 2, 3, 4, 5, 6. When you write it, you've got the one digit, 5 point, and then every other non-zero digit gets written as well. So the 6 is included, the 7 isn't included. Since all the rest are zeros, that's what we're writing as powers of 10. So 5.67 times 10 to the 6. Those are considered not important values. I shouldn't say that. I don't want to make them feel bad, but 5.67 times 10 to the 6. Where does the 6 come from? Because that's how many times we had to move the decimal to get it where we want it. So there's only one non-zero digit before it. Claire?
Why did you write an x as the multiplication sign instead of a
Good question, because I did say earlier that we don't use the x. This is the one exception, okay? The one exception to when you do use x for multiplication is with scientific notation. Again, it's a sciencey thing. Science is weird. I don't know. But yeah, I'm glad that you're paying attention for it. This is the one exception to that. Rowan?
Not gonna lie, I was kind of dozing off in the first part, so I thought 4.91 plus 10 equals 11 was 10 inches.
Okay.
Same way.
So don't do that anymore. Damien?
Could you still use the dot? Or do you have to use
No, for scientific notation, you should use the x. That tells you what type of notation we are using here. Jalen? Yes.
No.
Okay, next one. 878 trillion. How many times is that decimal moved? Right now it's at the end, because it's not written, so it's way at the end there. How many times is that moved to get to scientific notation? We want it. There's only one non-zero digit. Will, how many times do you have to move it? 14 times. It's got to get, so it's 8 points. Let's go in groups of 3. 3, 6, 9, 12, and then 2 hops to get right there. That's a total of 14 jumps. So 8.78 times 10 to the 14th power would be scientific notation. If you've got a really small number, like 0.00013, you see the decimal point is written. We still want to get it so there's only one non-zero digit to the left of it. So our goal here is to move this decimal so it's right here, between the 1 and the 3. But in this case, since we moved it to the right, to put it into scientific notation, that means we have to move it back to the left to put it as 0.00013. We're not going to use division here. We're going to use a negative power. So this is going to be 1.3 times 10 to the negative 4th. Okay? Negative 4th. Which direction on a number line is the negative side? Left. When you see a negative power, that tells you which direction the decimal point needs to go to get back to the original one. Okay? That last one, which two numbers do we want the decimal between?
The 1 and the
0.000004901. Which two numbers do we want to move the decimal between, Lucas?
4 and 9.
The 4 and the 9. Right? 1, 2, 3, 4, 5, 6, 7. The unfortunate part about small numbers is we don't use commas. Right? So you kind of have to count each zero individually there. But 4.901, yes, that 0 does get written in this case because it's between two non-zeros. So we need them all. 4.901, and then times 10 to the negative 7. Lucas?
How do negative exponents work?
Negative powers, we'll talk about that actually in CO13. But in this context here, it means that you need to divide by 10 7 times to get back to that original small numbers, because this is how, like when you multiply by 10, the point gets moved over to the right. When you divide by 10, it moves the point over to the left. Okay? You think about 4 divided by 10, well that equals 0.4. Just move that decimal over one spot to the left and you can continue on like that. Why is the exponent positive in these two here? Why is the exponent positive? What does a positive exponent tell you? What does a positive exponent tell you? Grace?
It's not a decimal.
Sorry?
It's not a decimal.
It's not a decimal. It's a big number. When the power is positive, it means the number started out big. What else does it tell you? As far as which direction the point gets moved, yeah.
Going left, going to the right.
Yes. The decimal is moved to the right to get back to the original number. Okay? Get back to the original number. The next one is negative, it's just the opposite. A negative power means the number is small. Okay? And the decimal is moved to the left. To get back to the original number. So understanding that, what the power is, what it means, a big part of understanding scientific notation. And that is as far as we're going to get today. Any questions, comments, concerns, complaints, comments, congratulations, criticisms on this? Matthew,
This is too long,
what's too long?
math lesson.
Same, it's actually shorter. I started at 9 o'clock.
It's only 9.
Same
Isn't
45
the
minutes
class
as always.
over in 3 minutes?
Yup.
That means it's too long.
That's why we're stopping today. Lucas!
Can I use the bathroom?
When class is over. We only got a couple minutes left. Rowan!
Can I get an extra binder, at least, just sheet that's like this?
Look for it first. If you can't find it, then you've got the notes down on a separate sheet of paper.
Yeah.
If you find it, transfer them. If not, then I'll give you a new one, then transfer that. At least give yourself a chance to find it first.
Okay.
Say a prayer to Saint Anthony.
What does this do?
There's no homework.
Oh.
No homework for tomorrow. Yeah. No.
Why not?
homework
Am I doing
tomorrow.
this in class tomorrow?
Yes, we'll do this in class.
Yay!
Okay, that's our math.
Yippee!
Don't forget to like.